What the hell is this? Call predefined API and guess no.
The fuck, nigga? The fuck, nigga?
So we're calling a API.
The API only returns it only returns whether our value we guessed.
Alright, let's do it.
Let's do it, bro. You think of a solution.
This is the same stuff, but with more context.
Okay, so do you have a solution?
Yeah. So we'll have middle, which will be our guess. We'll pass it in to the int guess, integer num, and have that guess result and use conditions based off what it returned. We'll put this in a while loop while the guess is not equal to 0.
Oh wait, this is easy. So we need to somehow like simulate. So we're basically guessing the number they picked using binary search in log n. So how do we want to simulate it, right? So we can, I guess, left could like equal to 1, and then right has to equal to n.
Let's use a boolean for this loop.
Yeah. In left is equal to 1 because there is 1 to n, and then right is equal to n minus 1. And then if middle is equal to wait, what? Oh,
If guess is higher,
so how do you call the API?
you just do like read the comment thingy, just call it guess bracket and then your argument. Oh, done. It's basically the same thing, just different context.
If it's equal to -1, so if it's higher, if it's higher than the number I picked, then we want to do right is equal to middle -1. So I guess it's equal to 1. Then we just do. I mean, what a return. What do you return? I mean, it will never get to this anyways.
I just did
But what do you
-1.
Yeah. Huh? What'd that mean?
Right? Well, I did different.
What do you mean the different? Well, can't.
I don't know if you meant to do
This
that.
is
I might get flamed if I use this.
why is it Why is it not n-1?
Because you're not doing like a.
Because you're not indexing.
You're not like getting a length of a list or something that starts from 0. The range is 1 to whatever they pick.
And I also get confused. Why is it like less than or equal to 1? Why is it less than and like? Why is it mix and matching, bro? So fucking annoying.
Alright, square root x. Oh shit.
Wait, bro. Yes, number lower.
Given a non-negative integer x, return the square root of x, round it down to the nearest integer.
Is this gonna require something like, oh fuck, I already did it? I had a solution saved, but I didn't look at it. It's alright. Given a non-negative integer x, return the square root of x, rounded down to the nearest integer. Return integer should be non-negative as well. You must not use any built-in exponent function or operator. But the thing is, like, we don't know the logic behind it, you know? We don't know the logic of square root.
What do you mean?
Yeah, because we can't use the power operator, we can't use the double asterisk icon. Like, do you actually know the formula for square rooting a value? You don't, right?
So it just divide.
So, get my solution, because I know you have to use binary search, but it's the logic which I understand. Yeah, so look, to calculate the value, it's going to be middle times by middle.
What's the logic in that?
That's the logic for squaring a number.
Is it?
Yeah, so it's middle times by middle. But is that not like is that not like exponent functions?
No, times is power. So while P1's more than P2, calculate middle. What was the thingy? Int. Int middle. So we square middle. If we square it and it's still bigger than x, then we decrement. If middle, wait no, s is bigger than x, then we p2, middle equals, oh shit, p2 equals middle minus 1. Else if middle s equals x, oh shit.
Like you would think this question is so simple because they just provide an input and you just want to return the square root of it. Like what would make you think that you need to perform binary search?
Why do I get an error in my middle times middle?
Because you need it long. You need it long.
I did.
Oh, the data type needs to be long as well.
Yeah?
The data type needs to be long.
Oh. That's what you had in.
Yep, add long.
returning.
Return right. But do we even understand it?
I get it.
Do you understand?
Yeah.
You run through a simulation. You get it, but if you get the right answer, nigga.
Alright. If S bigger than X.
What is your P1 and P2? Is that right? You get P1 and P2, right? At the start.
Oh my fuck. No, I actually get the logic there.
Alright, go on then, like.
Yeah, so you have X example as like 16. So we'd have P1 at 0, P2 at 16. So basically, we have middle at somewhere at, what's the middle? 8. Mid is 8. Now we calculate the squared. So square root of 8 is 64. S equals 64. So now S is bigger than 16, which is X. So it'll go down. So P2 is now 8. So P1 equals 0. P2 equals 8. And middle
We got a
equals
7,
4.
wouldn't it?
Huh?
P2 would be 7.
7?
Because it's middle minus 1, is it not?
No, just do it this way. But then now middle will be 4. So what's 4 times 4? That's 16. So now it actually reaches X.
See.
So we're just working backwards from the square root.
Interesting. And now why do all of the solutions use left as 1 and right as X? Why does 0 also work? Does it matter?
What do you mean?
Like you can change the 0 to 1. So it'll be 1 all the way through to X.
Something to do with square root, probably. Would brute force just be square rooting from 0 to X? No, that's so.
Yeah, I mean, I guess that could be it. Wait, so what would the brute force be? It'd be like a for loop, right? So for each number, you calculate the square root, right? The square root of that number. And if the square root of that number equals the input number. So what's the square root of 1? 1 times 1, right? It's 1. And if the input was 1, then
Just return it.
if the 1 is equal to 1, so you return
You'd calculate 1 times 1, you equal 1, and then return that. Didn't you do Coco's eating bananas?
I did. It's hard though.
Yeah, I'm not doing it. Capacity to ship packages. You do that one?
Nope.
No?
No, I didn't.
73%.
Lucky. Okay. Coco eating bananas. What's the percentage on that? 49.8. Fucking hell. Yeah, that one is hard, bro. I'm not gonna lie.
Alright. Let's do this one, then we'll do revision. Or we
Okay.
can do more. A conveyor belt is packages that must be shipped from one port to another within days. I package on a conveyor belt has a weight of weights. Each day we load to ship the packages on the conveyor belt in order given by weight. Return released weight capacity to ship the return. So we have weights, 5 days, output is 15. Ship capacity at 15. Okay, so how do we approach this? First day, 1, 2, 3, 4, 5. Second day is 6, 7. Third day is 8, 9, and then 10. And the given limit. So some of the questions are not in sorted.
I think it matters. We're meant to use binary search in a different way.
Does binary search work without sorted?
Nope. But you're meant to use it for a different concept, like, because you're not always iterating through the list provided. You're iterating through something else. It's the same as Coke is bananas. You gotta use it on something else, not the actual list. This question has 70-something% acceptance. It's kind of crazy. Like, you wouldn't think that, because I can't figure it out already.
You know what I mean? So how would we use the possible function? How do we get the limit? What would determine where we start the limit and how we move it?
I think one thing we can do, right, is we can add all of the numbers together and divide it by the number of days, right? So in the very first example, that would be like what? 1, 2, 3, 4, 5, 6, 7, 8, even 10. I don't even know. I need to calculate for that.
19, 27, 34, 40, 45, 49,
55.
52,
So 55.
55
55 divided by 5.
is
11.
11. So we can have 11 as the middle point and use a possible function. And depending on if it's possible or not, we increment or decrement the middle. I meant the pointers. Wait. Would you even need P1, P2? We'll just
It's
have
binary search. I feel like it would, yeah. Alright, let's get the first hint. Binary search on the answer. We need a function, possible capacity, which returns true, and only if we can do the task in D days. So create a function called possible. Dan, did you really look at the fucking thing?
No, just now. Binary search on the answer. So how does that work? Unsorted. We will... Maybe the middle will be like the endpoint from P1 to middle included in a single day. And that'll be the limit. No, it's
Hold on.
limit.
Let me quote. Okay, so we're gonna have some answer, and using our answer, we need to run the possible function on it, and that returns true if we can do it in that many days. So what answer are we actually having? So our answer would be the capacity of the ship, right? So we're checking if the capacity is possible. But how are we even meant to derive the capacity? Like how are we getting this capacity number, right?
Wait, we need to think.
And we shouldn't assort the array, should we? Like,
No, I think... Wait,
because it matters, the order matters.
does it? No.
Yeah.
It does.
Yeah, the cargo must be shipped in the order given. So using a ship of capacity 14 splitting the packages to that, it's not allowed.
So maybe the limit...
So we need to work through it left to right. So I guess one way we can do it right is we can use binary search in the first function, I reckon. Because we want to binary search on the answer.
What is the answer?
I think it might just be middle. Oh, but it's not sorted.
Yeah, that's the thing.
And I don't really see why you'd binary search in the possible function. But maybe you do. A ship of capacities that we just want to find a capacity, the minimum capacity. I'm thinking maybe you do want to sum together all the weights then divide it by 5.
Okay, and then you have the answer there, but then what do you do with that?
So that's assuming like the ships of 11 can distribute between 5 days, right? And then we'll quickly realize that okay, that's not going to be valid. You're going to need a bigger boat for each day. So once we do that, once we know that we need a bigger boat, that you can either just continuously increment it by 1 and then just check over and over and over again. One thing is, can we obtain the difference? Like, can we somehow find out how much we're off by? One, two, three, four, 5, 6, 7, 8, 9, 10. I don't think we have to worry about this in particular. Maybe we do. Let's go to the discussions.
This guy's fucking...
Yeah, it gives the impression that the rating question must be sorted. However, in reality, binary search only cares about a sorted search space. Most people assume the search space of the binary search algorithm has to be specific elements at a given index in the array. Because of these examples, people tend to be shown when learning binary search. In more advanced binary search ones, such as this one, the real trick is figuring out how two things, the search space and the condition. That's what I was mentioning earlier, like it's not over the array, it's something else. In this problem, the search space is the range between the minimum possible capacity of the ship, which is the max weight of a single package in the entire array, and the max capacity of a ship. It's just total of all the weights of the packages. So it's going to be the max in the array, and the max of the ship, which is the total capacity of all ships. We can justify this by realizing. Okay, so just using that information, let's see if we can figure it out. So we know the highest value in this one here, right, is 10. So 10 is the highest. And then the max of it all is 55.
Try a different one, not sorted. No, it doesn't matter.
Okay. Alright, we'll do this one here then. So the highest in this one is 4. And then the highest is 3, 5, 6, 7, 11, 12, 16. So it'd be 4 to 16, right? So how can we use that? So it's sorted. We know it's sorted.
So we can just have like a range 4 to 16, like 4, 5, 6, 7, 8, 9, 10.
Yeah. But what does that actually mean? Is that just it?
I think that's what we just put into possible, is it not?
Yeah, I think it might be. So we can. So we run a for loop in here within that range.
Wait, why is your thing look different to mine? Your functions.
Because I checked the hint. If you look at the hint, right, we need a function possible capacity which returns true. If we can do the task in DDEX.
Why is your parameters different?
Because it just takes capacity.
Oh, you changed it.
According to the hint.
Okay. So let's do the binary on the range with the middle being past possible.
Honestly, let's finish off this fucking comment.
Yeah. if weight's P1, if weight's I bigger than P1, and P1 equals Y. So now we have the highest, which is 10, plus we have the sum, so that's a range. Now we'll do the while loop. So we'll have while P1 is more than P2, we will calculate possible with middle. We'll calculate middle first, and middle plus P1 plus P2 minus P1 divided by 2.
How did you get the max? The max in the array?
I just use I had to iterate the whole thing. Wait, Boolean possible. If it's not possible, how do we know to increment or decrement?
Yeah. I don't know how that boolean. I don't know what the possible functions will be implemented like, to be honest.
So if we have this here, we have what was your comment? Four and 16. Middle equals 4 plus 16 was 12. 16 divided by 2 is 8. So that's our middle. So we pass middle into possible. Wait, it's always going to be possible starting from higher up.
Huh?
Like, if we have, example, the output limit as 100, it's always going to be possible. So we'll always be decrementing, incrementing if it's not possible.
Dude, how does this have a 73.6% acceptance rate? So what do you say? Like, my monkey in my room. I have to take off my offense. Nigga.
What? How do you do a possible function? Have all the packages in 5 days. We would iterate through.
You need to do something to check valid. Some niggas aren't even using helper functions.
What happened? Oh. I'm checking chat. I don't know what's wrong with mine. Current shift plus smaller equals, then current shift plus equals weights. So if result equals true, what now? What? What's wrong? Please what?
This helper function isn't actually necessary, right? But like, I guess like it's helpful.
I used it. Where's it gone now? This is fine. While P1 smaller than P2, calculate middle, get the result, best of the result, P2. So basically, if result is true, then you shouldn't always return true because that's not the minimum. So that's why you decrease pointer 2 until the loop breaks and then return P1. I don't know what's wrong with marking. Current ship 0. Current ship plus weights I is smaller than or equal to current ship plus equals weights.
I mean, I understand that now. It's just I don't know why it does it like
Why is it
that.
not equal 0? I'm checking chat. I give up. Oh. I did my for loop with a -1. That was decent.
Definitely, it's a good question. It really like shows you how binary search could be used differently. I think it's that common. Honestly, I kind of now actually realized that I knew something about binary search involved that shit, but I wasn't quite sure what it was. But it's like different search spaces. That's the key. And then like the logic he provided with it was like, a ship must hold at least the largest element in the array combined with the total of the array. And that makes sense. There's a bit of logic we needed to formulate that search space. Like that go. Also, you wanna fuck revision and help me with my thingy?
Okay.
Help me with my test. Sit aside around an hour in a quiet place.
Wait, you have to
Work
record,
this.
do you?
I don't think I need to record. It doesn't say anything. I need to check the values. KPMG values. I mean, I doubt I'm even gonna get a
I'm
fucking
asking
message back.
questions.
Can I get like a more detailed